Here's our packaging for the indicator stand in 3 points. We have the indicator swivel. This mounts to your indicator. You can set the tension of the pivot, and this mounts your indicator using an Allen wrench, and it just hooks onto the back with this dovetail. Here's what makes this whole unit really unique. Inside we've got spring-loaded ball bearings. The face of that screw has been ground square. We only ride on the chamfers of this column. Nothing else is touching but the ball bearings on the very back surface. So what makes this great is we have tension, and so it never drops when you loosen or tighten the screw. And that's what you need for an indicator. You don't want to damage your indicator by dropping it. But it's super strong. Once you just tighten it snugly, it isn't going anywhere. It's a very, very good system. We can quickly pull it off, flip it around if you're going into checking things for perpendicularity. This is what makes this system so unique. Installing the indicator stem is real simple, just a quick adjustment. And now you can do over and under. So you can adjust your indicator for underneath something, and you can adjust that at any height, or you can just lower it and you're ready to go for checking the top of parts. All right, with our 3 points here, this is how we're going to check flatness. And it all starts with the surface plate, and this is at a reference. And what we're really checking is parallel to the top of the 3 points from the referenced surface plate. So with the indicator at a 0 and the part suspended on a plane, we can now compare how flat this surface is in reference to the surface plate. So now we're checking parallel. We know one side is flat, and so everything we are checking now is what's called parallel. Perpendicularity. And the way perpendicularity works is these walls are either a true 90 degrees, or they're leaning, or they actually have some sort of a bowed condition. And you can find that using the perp. Now, we have already checked for flatness, parallel, and now we're going on to squareness. Now, a lot of companies will tell you you need to buy a cylindrical square to set a 0 on your indicator. That's one way to do it, but you don't really have to. Everything is relative. This whole block is ground well within 1/10 of squareness. So we have some sort of good reference. I can use it to a certain degree of accuracy. Now, because this thing is out by about 1/10, it's leaning one way. What that means is whatever reading I get on this, when I'm checking one side, it may show it's 1/10 out. When I flip it around and check the other, it's gonna double it on the other side, because this has been set to a 0 from over here, but this one's leaning over that way, if that makes sense. And so this one's a plus, this one's a minus, and I'm gonna show you right here. So when I come in and I pick up this block right here, we are sitting right at 0. When I flip it around, the side will be slightly off. And there it is, maybe 80 millionths right there. So, and it's doubling the error. So it's out TIR, total indicator reading 80 millionths, but what it means, it's only 40 millionths out of square per side. And this is a little tool maker cheat, is you take that 80 millionths and you dial that into the 50% mode right there. Put that right in the middle. So now I'm plus or minus 40 millionths there. This side will say plus. Boom, it goes to the plus. So basically, you can create your own 0. You don't have to have a cylindrical square.